So we have covered about the introduction to IoT, where we discussed about the definition and characteristics of IoT. So basic definition and the components of IoT we have discussed. So when we talk about the physical layer design of IoT, we started talking about the hardware components that are required for IoT networks, and we discussed about the sensors, hardware microcontroller boards that are normally used in the IoT system setup. So after that, we discussed about how what are the IoT protocols that are normally used in IoT systems. So these are the things that we are talking in this lecture, and we will discuss about the application layer protocols mostly. So in the physical layer and data link layer, we discussed about IoT protocols such as Bluetooth, Wi-Fi, like cellular communication, Ethernet, LoRa, ZigBee, so on. The network layer, we discussed about protocols such as IPv4, IPv6, and 6LoWPAN protocols. In the network layer, 6LoWPAN protocol is one of the popular protocols that are used for IoT networks, and it provides more energy efficient features than IPv6. So when we look at the IPv4 and IPv6, both addressing schemes in the network layer. They provide the unique identifier for each devices that are connected to the network. And if we take a local area network, a router is responsible for assigning unique IP addresses to the devices and to the devices that are connected to the router. If we have a big, large scale company and the related network, then the devices in that network, in that large company, will be assigned through a certain server, which we call as the DHCP server. And then that server will be responsible for assigning the IP addresses. So anyway, like we have different IP address types, IPv4 and IPv6. IPv6 is more popular because it is able to produce more unique addresses than IPv4, and it has therefore the ability to provide the addresses for massive number of devices that are there in the network. So when we talk about the IP header will contain fields. So there will be multiple fields included in the IP header. So when we take those fields, one of the important, or one of the some of the fields available are like packet length, time to live, source address, destination address. So when we take the time to live, now packet length, of course, like packet length is giving us the size of the packet. It could be in bytes or any other format like bits, bytes. So it will give the size of the packet and a size of the data that is stored in the packet. Then when we talk about the time to live feature, it gives us the maximum number of hops that a packet is forwarded in the network until it is discarded from the network. So this time to live feature is available because in order to prevent the same data getting circulated in the network for infinite time. So normally if we transmit some data, we normally wait until we receive some feedback from the receiver, or else if we don't receive any feedback or any kind of acknowledgement that our packet has been transmitted, then we retransmit the packet. So because of the retransmissions and because of the acknowledgement schemes that are available, so there's no need for us to keep the same packet circulating in the environment or in the network for a long time. So in that case, we tend to like discard it after the time to live uh, time to live uh, duration. And then in a packet, the source address, destination address should be mentioned. So this is analogous to a situation where we are sending a letter from one location to another distant location in the in our let's say in a geographical area. So if a person wants to send some post, they have to first mention the address, the uh, sender's address, and the receiver's address. So the sender's address can be written as the source address, and the destination address could be the this receiver's address. So once these two addresses are given to the packet header, the packet header will be read by the routers which receive this packet in the network. So once the routers receive this data, the router will check like what is the optimal method to transmit that data to the end destination. So in the internet, that procedure is happening at each router, and the routers are forwarding the packets to the end destination. So until the end destination is reached, the packet is forwarded across multiple routers and switches. So the source address and destination address are the kind of the most important factors in routing the information. At each hop, the node, the intermediate node or the router decides the next best node using a routing table. When we talk about the IPv6 protocol, which is the protocol that I mentioned before, which stands for Low Power Wireless Personal Area Network. It is a protocol that is widely, proposed and suggested for IoT networks. So when we talk about IoT networks are energy hungry networks where the network is unable to, unable to I mean, a network is actually constrained in energy. So the network is like unable to keep the energy sustained for a very long time if there's no external power supply. So in cases where we have the low power and uh, low bandwidth scenarios, and we want to do the communication using an ad hoc network, then we have to use some optimal protocols to transmit our message. So what is meant by that is that if the energy consumption in our networks is higher, or else we are sustaining with only a low amount of energy, then we have to reduce the energy consumption. So for that, we have to go for low power and low power mechanisms to transmit our data. But from that, in this environment, there's low bandwidth communication. So which means that every device is given a certain narrow frequency range to transmit their data. So therefore, the devices are only able to use that specific narrow bandwidth or the narrow frequency band to transmit the message. So the ability to achieve high data rates is also challenging in this low bandwidth communication. And if these low power, low bandwidth situations are available, and the ad hoc communication is also um, necessary to do the communication, then we need to use optimal protocols to transmit the message. So IPv6 over low power wireless personal area network is a protocol that is proposed for these kind of networks. So for low power, low bandwidth ad hoc wireless communications, we propose the 6LoWPAN protocol. So the main speciality in this protocol is that it allows IP header compression that makes the packet size more smaller than the actual IPv6 packet. So the maximum size in a standard IPv6 packet is around 1024 bytes, whereas in 6LoWPAN it's about 127 bytes. So in the 6LoWPAN, the packet size is smaller, therefore we are able to send short packets to send our data. The 6LoWPAN protocol is used therefore for constrained environment, and it is therefore useful for low energy, low bandwidth scenarios. So low energy or low power and low bandwidth scenarios. So in there we can actually use IP addressing scheme, IPv6 addressing scheme to address the nodes. However, like on top of the IPv6 addressing scheme, we apply this 6LoWPAN protocol to make the IP header compression. So IP header compression basically is allowed in this 6LoWPAN protocol, and it allows us to reduce the packet size into about 127 bytes. So packet header compression can reduce the packet size considerably. So in normal IPv6 packets, the packet size is about 1024, and it consists of all the packet header fields that gives information about different aspects of the packet. However, such things are compressed in this 6LoWPAN packet, and then the size is reduced up to 127 bytes. So this protocol, 6LoWPAN protocol, is a network layer protocol. The network layer protocol. So when it's functioning, it can function on like physical layer communication technologies such as Zigbee, Wi-Fi, and so on. So it can function over communication layer protocols such as Zigbee, Wi-Fi, and so on. So it can work on top of the available physical layer protocols, and it can function in the network layer, in the network functions. So it can adapt with many physical layer protocols that are available, and it can customize the network layer performance. So the 6LoWPAN protocol can customize the network layer protocol, which is functioning on the existing physical layer protocols such as Zigbee, Wi-Fi, LoRa, Bluetooth, and so on. So 6LoWPAN can be integrated to multiple communication layer protocols. Physical layer protocols, right? It can be integrated over physical layer protocols, and it can function, can do the functions over the network layer. So this 6LoWPAN protocol is highly popular for IoT networks because of its low power consumption and its ability to transmit shorter packets and save the energy in the transmission and in the network layer communication. And then it is used for smart meters applications such as smart meters, smart homes, etc. So basically, this is the kind of the environment where 6LoWPAN protocol is used. So 6LoWPAN protocol is applied for the network layer transmissions of the data from one device to another device. So if I try to draw the same figure, so if we have multiple nodes which are trying to communicate with each other and which do not have direct communication link with the main network infrastructure. So if we take the main infrastructure to be cellular infrastructure, which is the kind of like, I will say, this is the base station or the GNB, and then this GNB is connected to the core network through its fiber cables or any other medium, and then the base station is connected to one of the nodes in the network, in this ad hoc network, right? This is the ad hoc network, which is not connected directly to the main infrastructure, main network infrastructure. So this, the edge device, which is at the edge of the ad hoc network or at the edge of this coverage, right? So this edge device, which is at the edge of the communication network, right? So it provides the link to this ad hoc network. So this edge device, it could be a router, could be another access point, right? Could be another intermediate access point. It can provide connections to the ad hoc network. So this router or the access point is at the edge of the coverage of the base station, right? So the network infrastructure has a certain coverage limit, and at the edge of that coverage limit, this router or the access point is available. And through this router, the ad hoc network can gain access to the network infrastructure. So in cases where we have networks like this, where we have ad hoc network, or ad hoc means that it is a self-sustained network. It is functioning on its own. It's a self-sustained network, and this network is able to do the functions of communication and communication on its own. The self-sustained network can do the communication between in that network on their own, and they use their own standard rules to do the communication. So they don't need a specified frequency band to do the communication. The network itself forms the frequency bands to do the communication. So most of the time, the frequencies that are used for communication between devices here will be unlicensed frequency bands, which means that they are in the unlicensed frequency band, and which can be used by anybody to transmit messages. So the licensed frequency bands are normally used by the base stations to do its communication, but there is a frequency band which is not used by the standard cellular service providers or communication service providers. So those frequency bands that are not used by the companies are used by these kind of ad hoc networks that comprise of devices which are communicating with each other without using the specified or standard frequencies, but they are using the unlicensed frequencies. So they will be connecting with each other, and they will be doing the communication, and the communication will allow them to transmit messages between themselves, and if needed, they can communicate with the network infrastructure by communicating with the edge router and sending that data to the GNB and then to the core network. And from that core network, it can be connected to the internet. And from the internet, it can connect to any other device. So the communication can come, and the communication can be transmitted all over the, over to the standard network infrastructure, and the message can be transmitted to any point in the internet. So, so specifically talking about this ad hoc network, we need to use this 6LoWPAN protocol in the network layer to transmit the packets. So these devices will be transmitting the packet using this 6LoWPAN protocol, and then 6LoWPAN protocol is using short packet for the data transmission. So the amount of energy that is used by the devices to transmit the packets will be lesser because the packet size is lesser than when compared to IPv6 and IPv6 basically. And IPv6 is having a packet size of 1024, and below that we can send the packet using the 6LoWPAN protocol. So that is basically regarding 6LoWPAN protocol, and it is used widely for ad hoc networks, and it is therefore useful for IoT scenarios as well. So when we talk about the other layers, apart from the network layer, we have the transport layer protocols, which are basically the TCP and UDP protocols, which are transmission control protocol, and user datagram protocol. So these two protocols are the standard transport layer protocols that are used for other applications as well when we consider about data transmission. So in any kind of communication network, we basically use TCP and UDP transport protocols, and they are not specifically useful for IoT networks. In general, they are the transport layer protocols. So these are the main protocols that we will be using. So the transport layer protocol that we will be using for a certain IoT application will depend on the application layer protocol that is used. So based on the application layer protocol, most of the time the transport layer protocol is determined. So based on the nature of the application and the requirement of the application, the transport layer protocol will be determined. So we need to keep that in our mind, that we need to decide the transport layer protocol based on the application protocol that we are using. So the transport layer protocol is basically decided. This is decided by the application layer protocol that we are going to use. So the application layer protocol that 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 we are going to use is also depending on the certain application that we are trying to achieve. So if the application requires some kind of a performance in terms of reliability, or in terms of latency, in terms of energy efficiency, in terms of complexity, so security. So these, some of these metrics are, considered by the application, by the customers when they are using this application. So customers require some sort of performance from this application. So based on that performance that is expected from this application, the application layer protocols are selected. And based on the application layer protocols and the application, the transport layer protocol is decided. So most of the time we decide the transport layer protocol after deciding the application layer protocol. So when we talk about the application layer protocols, there are basically several application layer protocols that are useful for us. So when we talk about the application layer protocols, there are several protocols. However, like for IoT scenarios, we'll be discussing about basically this MQTT protocol, which is the message queuing telemetry transport protocol. So MQTT protocol we will be discussing about, so which is message queuing telemetry transport protocol. Also, we'll be learning about another protocol called 6LoWPAN protocol, which is another protocol that is used for IoT specific applications and other applications as well, but it is useful for IoT networks. And when we talk about other protocols, HTTP protocol is again another protocol that is useful for IoT, where we use where we are focusing about web browsing and obtaining resources from the web. So based on the application, we will be using that protocol. So HTTP protocol we will be using based on the application. And then there are other protocols as well, WebSocket protocol, and so on. There are several other protocols that are popular in the application layer protocol, and based on and when we focus on IoT, such protocols are widely used. So we will be talking about this MQTT protocol first, and the MQTT protocol um, is um, is actually having some features that are different from the other protocols such as CoAP, HTTP, WebSocket. So we will discuss about those differences while we are discussing this protocol. MQTT was first developed by this Andy Stanford Clark of IBM and Alan Nipper of Eurotech in 1999. So it is proposed as a protocol that is that is that it was first proposed in 1999, and it was basically the main feature is that it's a lightweight protocol, and the major so we will discuss about the MQTT protocol using some figure as well. So the major difference between other protocols and the MQTT protocol is that it has the MQTT broker component in the communication, right? So in MQTT protocol communications, we have something called the MQTT broker. The MQTT broker is a server which is which is uh, which is available in between two devices which are communicating with each other. If there's a device number 1 and device number 2, then MQTT broker facilitates the communication between device 1 and device 2. So in this MQTT protocol communication, the direct communication most of the time does not happen, but the communication happens in between by through this MQTT broker. We first send the data to this broker, and the broker sends the data to the necessary receiver. So when we take other protocols such as HTTP, so in there, of course, we have the chance to connect with the device number 2. We directly communicate with the device number 2 by sending a request, and the device number 2 will send a response directly to the other device. So this kind of communication is a direct communication between the transmitting device or the source device and the destination device, or the host device and the client device. However, in cases where we don't have this communication situation, or this kind of scenario where we have direct stable link with the client or the other device, then we have to go for other protocols such as MQTT. So in the MQTT, we have this MQTT broker, which provides the intermediate functions of the communication. So when we say something like, uh, right, so when we say the MQTT protocol, it is actually composed of three parties. First one is the publisher, the device that is publishing data into the broker. So broker is a certain server or a computer that collects the data that is sent by the publishers. And this data that is sent to this broker will be like stored as a list. So there's a certain topic, and under the topic, the data that is sent from this device will be stored. So the whatever the topic that the device has considered will be taken into consideration So if the device 1 is sending temperature data, then the topic will be temperature and the value will be some kind of temperature value. So it could be 30 Celsius. So the MQTT broker will store the data in its server under a certain topic, and the value will be stored. And so if the value is changing over time, it will be stored in the broker, and with the time it will have different values. So the subscriber is the device which has subscribed to one of the topics in the broker. So if the subscriber has subscribed to the topic temperature, then the subscriber will get the temperature information from the MQTT broker. So depending on the request time, the broker will send the data that is requested by the customer, and the broker will send the necessary or required information to the subscriber. So the subscriber is able to get the temperature data by subscribing to that temperature topic. The subscriber has to subscribe to the topic. Publisher has to publish to the topic. So the topic that is considered in here is the temperature topic. So this kind of communication that happens between a publisher and subscriber with the support of a MQTT broker in between is known as MQTT protocol. So the main difference here is that MQTT broker is tableizing, or creating a table of topics and values that are received by it. So it has specific topics and values of that specific topic. And so if we take this MQTT protocol, we can consider this as publish and subscribe model communication. Also, this is this communication is very much similar to TV and radio broadcast, right? So it is a situation where, like, this is similar to TV and broadcast. However, it's actually different from MQTT protocol. Because I will explain first. Now, TV and radio broadcast means, like, the publisher, if it is TV and radio broadcast, the publisher will be TV, and the TV will publish data into a certain topic, and the subscriber will get that topic data by subscribing to that topic. That means that TV or broadcast station will publish the data under a certain channel. There are different channels. So channel 1 will get data once whatever the publisher wants to publish in the channel 1. So if there's data in the channel 1, then the subscriber who has subscribed to this channel 1 will receive that data. So there could be several data in here. It could be channel 1, channel 2, channel 3, likewise. So if the subscriber has subscribed to channel 1, he or she will receive only that data during that time. After that, the user or the subscriber can also subscribe to other channels also. So once the channel is subscribed, that specific channel data will be sent or transmitted to that specific subscriber. And then, so the difference between TV and radio broadcast communication and this MQTT protocol is that in the MQTT, the subscriber who is listening to some kind of data can also act as a publisher. So that means that there's no specific person that is dedicated for the publish or subscriber roles, which means that this person who subscribed can also act as a publisher, right? It can be also a publisher. Each and every device which is connected to the MQTT broker can be considered as a subscriber or a publisher, right? Even in here, it could be subscriber or publisher. So therefore, any device can subscribe to a certain channel in the broker or publish to a certain channel in the broker, right? However, in the protocol, the standard name used is topic, So we don't use the channel word channel. Normally we use uh, the term topic. So we consider that the MQTT broker is having a list of all the topics and the values related to that topic stored inside the broker. So the MQTT broker keeps a list of subscribers. When a client subscribes to a topic, the broker adds the client to a list of subscribers for that topic. So, once there are multiple subscribers to a certain topic, the broker is adding the client or adding the client uh, to the adding the subscriber to the other rest of the subscribers who have subscribed to that topic. So for a certain topic, there could be several subscribers. So subscriber 1, 2, likewise up to n subscribers, there could be there for a certain topic. So the MQTT broker is allocating, or the MQTT broker is defining or categorizing these subscribers and organizing these subscribers under a certain topic. So the broker is responsible for organizing the subscribers under a certain topic and organizing the number of publishers or the publishers under a certain topic. So the broker is basically responsible for organizing the data inside the server. So the basic two functions that are done through this MQTT protocol is basically the publish function and the subscribe function. So the MQTT protocol does the publish of data and the subscribing to data. So when we are talking about this protocol, we have to have methods of implementing it. So in the so I will explain the MQTT protocol using an example as well. So in this example, there are sensors that are placed around the earth, which could be temperature sensors, humidity sensors, other weather data sensors. Then these sensors, which are placed in different positions in the world, can take measurements frequently. So if we have data like that, we can publish such data to MQTT broker or a MQTT server, which is connected with this server, sensor nodes. So we connect our sensor nodes to this MQTT broker by initial configurations, and then once we are connected, then we are able to send the temperature data frequently to the MQTT broker and update the values in the MQTT broker. So there could be several subscribers to the different sensor measurements, and if there's a client which or who has subscribed to vibration topic, then that data will be transmitted to that subscriber who has subscribed to the vibration topic. So apart from that, if there's another client who has subscribed to the temperature data, then the temperature data will be transmitted to that certain subscriber. Apart from that, the databases will also be able to store all the data of the temperature, humidity, weather in a large database where you can keep the data for a long time. So the broker can also transmit data to a certain database and can store the data there. So the broker is actually responsible for sending the data as soon as it receives from the publisher to the subscriber. So MQTT brokers, there are mainly about two types of brokers. One is the managed broker, or these brokers, which are managed brokers, are basically third-party brokers. So these brokers are fully controlled and maintained by these companies. Like, for example, companies like AWS, Amazon Web Services, Azure, Mosquito, HiveMQ. They are third-party companies who can run the Mosquito broker and run and give us the services that we require for our application. So also Mosquito and HiveMQ also provide us open source Mosquito servers and open source like Mosquito server softwares for us to access the Mosquito servers, which are freely available for us to use. So self-hosted brokers Mosquito, Hive, and Q, they can be implemented in our own servers or in our own laptops, in our own devices. And we can set up a server on our own device. So we don't need to request for external devices or external resources from from another location or that is owned by another person. So we can use these Mosquito Hive MQ softwares and we can download and we can use those softwares in our computer. So basically there are two types: managed brokers, self-hosted brokers. So in the last interactive class, we discussed about how to set up the MQTT broker in our computer. So right. So I think we will discuss about that installation as well. So you need to you need to go to the Mosquito website, Mosquito MQTT website, and then from there you can download the download the installation setup, from which you can install the software. So after installing the software, you can actually access the server. I mean, you have to first do some configurations to set up the Mosquito properly in the computer. So after that, you can allow the server that you have installed or you have set up in your computer to be accessed by other devices. So we need to actually set up this MQTT broker through certain software that are already available to us. So I think in the last interactive class, we discussed about how to install the MQTT broker, and I think we had some problems in installing. Anyway, I think we will now discuss about that further. So anyway, like before that, I think I will also try to do the installation now, and we will try to see whether it works. So before that, I will share the attendance. If possible, mark your attendance. So I think that you have already installed the mosquito software in your system, right? So you can find whether you have installed by going to the folder where you installed it. So my one I have installed in the C deliberately because I want to access it very quickly. I have installed in the mosquito in the C folder directly, and I can go to the files in the mosquito folder from that. And in here, actually, this is basically the, content, and you have a file called mosquito.conf file, and this file decides all the important information that should be considered when configuring the mosquito. Server, right? MQTT server. So the MQTT server can be configured using this configuration file. So the different parameters can be set to true or false from this file. This is an important file, so it should be there. Apart from that, there are other files as well. So in order for us to know that this mosquito, I mean, uh, this software is working, we have to go to CMD or command prompt, and we need to run it as administrator. So without running it just like this, without running it as a normal command prompt, we need to run it under administration. So we have to go for run as administrator. So it will be giving us some kind of a message. It would give us some kind of message, and we have to open the command prompt under the administrator. Sorry, your okay. Have a message from one of the students. So I will share the attendance screen again. Is it okay now? Is it okay now? So I think I will go back to the network administrator, and then in here I had to write. Now I have these commands are actually like standard commands that you can use. So one thing is you can actually go to this and just type net start mosquito, and then you will be able to see whether it has already been started or not. Which means that if you are not using the mosquito service, it will show it is not available or the service is not there. But if it is already like functioning and it is working, it is currently available, then it is known as it will show as like the requested service is already started. So I can also stop the service by net stop mosquito. I can stop the service, right? And if I stop the service, then I cannot access the MQTT server through the software that we are going to use, that we will be calling as MQTT Explorer. So anyway, we will start the mosquito service. So and it will give us a message saying mosquito broker service was started as successfully. So then we will go to the MQTT Explorer. That is another software that we need to install, which is available in the Google. you can type and you can obtain the MQTT Explorer service. That will give us an interface like this. So you can download this MQTT Explorer and you can have an interface like this. So I don't know whether you got up to this point. You are able to, you are able to go to the, this is the standard host server that hosts the most MQTT server. And this server can be accessed through this host name. And we can obtain the data for that communication through this 1883 port. Once we get that is not connected, but sometimes if the Wi-Fi is not working or if some kind of connection problem is there, then we won't be able to access the server. Now, however, once we go to this server, you can see that different topics are there under different devices or different servers who are connected to this main MQTT server. So there are topics and under which they have published some data. So this is the test.mosquito.org server, and underneath that we have different data that have been published by different connecting devices. So in here, there is another option where we can create this. So we can create a new connection and we can connect. We can set the connecting device, connecting device, or we can set the IP address of the server that we are considering as a MQTT server in here. So we can set it as 127.0.0.1, which is our own IP address, which is used for setting up the network connectivity in the device. So this 127.0.0.1 will be used basically to receive the data packets that are sent to the MQTT server that we are installing in our own device. We can connect directly to that server. So this address is common address for any person, and any person can use the same address to set up an MQTT server in their device, and any person can access this address and send topics and data to those topics. So that is another way of publishing data into the MQTT server. Apart from that, when you are connecting when you're setting up the MQTT server using your own IP address, you need to follow a certain procedure to enable the connection to the MQTT server in such a way that the data is received to that server. So if your IP address is some kind of a IP address that you can find, find the IP address by going to the normal command prompt, or yeah, you can go to the normal command prompt and you can write ipconfig, and the IP address that you get here, you can consider as your local, device IP address. This IP address can consider as your IP address. You can put it as the hosting device's IP address. In here, when I directly type it in here, then when I say connect, it will give me a message saying that it is not connected to the server, which means that any data that is sent to this MQTT server that I have at this IP address is not getting sent or transmitted or received properly. The data that I'm transmitting or receiving um, uh, from and to this IP address is not getting connected or not being communicated properly. So the connection from this IP address to the server, or the server is in this IP address, but the data is not coming to this server. So because of that, we need to forward whatever the data that is sent to this IP address properly, such that we receive that data. Also, we have to make sure that the connection is therefore established properly. So in order to do that, we need to follow a certain procedure, and that procedure we will talk in the next class as well. In the meantime, I will put a link for you to refer in the LMS, and hopefully you can set up this connection using your IP address in here as the MQTT server's IP address, and you can get the connection properly set up using that method. So I will put another YouTube link into the LMS. Then you will be able to follow that. And if it is not working, we will try to solve that. So I think with that, I will end today's lesson. So if you face some problems in MQTT server installation so far, please let me know. And if you have any questions, you can let me know. Otherwise, we will discuss about we will also discuss about that in the interactive class. Also, I want you to bring like temperature sensor or ultrasonic sensor or some kind of a sensor in the interactive class to test out the MQTT connection and obtain data from the MQTT server, right? So obtain data from ESP32, and we are going to transmit the data to the MQTT server. So we are going to see that and test it out in the interactive class. So if possible, you can bring your sensors and bring your ESP32 microcontrollers to the interactive class. Also bring your MQTT server, a certain computer to work with, and to establish the MQTT server. So with that, I would like to end today's class. And if you have any questions, I will answer them. Otherwise,